All right, today we're going to unpack something really cool, a piece of tech designed to help us predict the future. We're talking about a whole new way to find that one critical signal that's usually buried inside a mountain of data. It's a clever idea that could really change how we work with complex information. So, picture this. You're running a massive factory. You've got thousands of sensors just streaming data at you every single second. We're talking temperature, pressure, vibration, the whole shebang. Now, somewhere in that digital tsunami, there's a tiny, almost invisible signal that's telling you a critical machine is about to fail. How on earth do you spot it before it's too late? That's the exact puzzle we're going to explore today.
Okay, so first, let's just get a sense of the scale of this challenge. That factory we just talked about, that's not some weird edge case. Whether you're in finance, healthcare, or engineering, we are all living in this era of just constant, overwhelming data flow. It's a true data deluge, and honestly, it often hides more than it actually reveals.
And this right here, this is what an analyst is often staring at. These endless, chaotic-looking streams of data over time. Now, traditionally, to find any kind of meaningful pattern in this mess, that required a super rare mix of skills. You had to be a deep expert in the field and a data scientist just to even know where to begin looking.
So there has to be a better way, right? A more intuitive way to see through all that noise. And this is it. This diagram shows you the core idea. The system builds this direct visual bridge between all that messy raw data on the left and a really interactive modeling space on the right. It's all designed to let a person literally play with the data to build predictive models. And the best part? No coding required. Okay, so the fancy technical term for what's happening here is time series regression. But don't let the name scare you. The concept is actually pretty simple. It's just a method of looking at how different streams of data have related to each other in the past to predict what one of them is going to do in the future. It's kind of like a doctor looking at your vital signs over the last few weeks to predict a future health issue. So what does this actually look like when you're using it? I mean, how does it feel? Well, the whole workflow is honestly shockingly simple. The whole complicated process of building a predictive model gets boiled down into just 3 basic steps. You plot the data you think is important, you highlight the time periods you want the system to learn from, and then bam, it generates a model for you to check out. Now this is step 2 in action, and it's probably the most powerful part of this whole interface. The user isn't writing lines of code. They are visually teaching the model just by highlighting parts of these charts. So you can highlight a section of normal, everyday operation, and then highlight the period right before you know a failure happened. You're telling the system, hey, this is good and this is bad. Go find the pattern.
And here's where you see that cause and effect. Over on the left, the user just clicks a few data streams from a drop-down menu. And instantly, right away, on the right, the system generates a brand new predictive model. You can see it as that dotted line there. If you change an input on the left, the model on the right updates in real time. It's a direct, interactive conversation with your data.
And all this brings us to what might be the single biggest advantage, the number one, and that's unification. Instead of juggling a bunch of different programs for cleaning data, then another for modeling, then another for visualizing, this whole invention puts everything into one single interface. It radically simplifies the entire process. But wait, how does the system pull this off so smoothly? How does it even know which data streams belong together in the first place? To understand that, we've got to pop the hood and take a look at the system's secret brain. So what is it? What's the foundational piece of the puzzle that makes all of this intuitive, visual modeling even possible? Well, the answer is something called an ontology. An ontology. I know, it sounds super academic, but the best way to think about it is as a family tree for your information. It doesn't just store bits of data, it stores the relationships between them. It knows not just who's in the family, but who's a parent, who's a cousin, and how they're all connected. So in the real world, what this ontology does is connect different things, like a temperature sensor and a vibration sensor, and it understands that they both belong to the same pump on the same assembly line. This context awareness is the secret ingredient, the magic that lets the interface intelligently suggest what data you might want to look at next, making the whole thing feel, well, intuitive. Okay, so let's zoom out from the tech for a second. What's the real-world impact here? Why does this kind of smart, human-focused design actually matter?
You know, the inventors actually put it perfectly in the patent document. They said, this approach provides cognitive and technical advantages over previous systems. In other words, it's not just better on a technical level, it's designed from the ground up to work better with the way our brains naturally process information.
So the benefits here are huge. Of course, you get insights from complex data way, way faster. But the bigger deal is that it sort of democratizes data analysis. It empowers the experts, the factory managers, the engineers, the people who actually know the systems best to test their own ideas in minutes instead of weeks. It lets them turn that raw data into a smart decision much, much faster.
And that kind of leaves us with this one big, fascinating question. A technology like this is about more than just making prettier charts. It's about changing our whole relationship with data, turning it from something you just look at into something you can have a conversation with. So what new problems could we solve in medicine, in engineering, in finance, if anyone, anywhere, could have a truly meaningful conversation with their data?